Here, we're going to talk about solving equations, and more specifically, these are one-step equations. So this should be a review for you from what you learned last year. We're going to skip the part about what you'll learn. We're going to go straight into the lesson. So the first thing it says is define formula in your own words. We already talked about what the word formula means. A formula is a mathematical equation with more than one variable. Okay. New vocabulary. Fill in each blank with the correct term or phrase. To find the value of a variable that makes an equation true is to solve an equation. So if you're solving the equation, you're trying to figure out what x or y or z is equal to. Okay? And equivalent equations, that's a tongue twister right there. Equivalent equations have the same solution. Vocabulary link. Solution is a word used in everyday English. Find the definition of solution using a dictionary. Explain how its English definition can help you understand its meaning in mathematics. So in English, the word solution is a fix or remedy to an unknown or a problem. So if you say, I have the solution to that problem, that means you can fix what's going on. So say, for example, your pencil breaks during class, the solution would be to get up and sharpen it. So you're fixing the problem. Okay. In math, a solution provides a value, kind of like the fix or the remedy, to an equation, to a variable. So in math, a solution provides a value to a variable in order to solve a problem. So you have a problem in math, you plug in the variable that makes it true, you have then solved that problem, you have found the solution, you have found the fix to whatever mathematical equation problem that you are given. All right, moving on to the next page. We're going to talk about how to solve equations, first using addition or subtraction. So for example, adding the same quantity to two equal or balanced amounts will yield scales that remain balanced. So you can always think about an equation as a set of balanced scales. Okay. For this particular equation, we have h minus 14 is equal to 13. We would add 14 to both sides. Quick review of properties. That is the addition property of equality. The addition property of equality. When you add the same number to both sides, addition property of equality. If this had been h plus 14 equals 13, we would have subtracted 14 from both sides, and it would have been the subtraction property of equality. All right, solve by multiplying. So we have 4 examples. First 2 are solved by multiplying. I give myself a little bit of space here. I always expect to see your work. We have g divided by 4 equals 7. We see division, so we're going to use the inverse operation, meaning we're going to multiply. And we're going to multiply both sides by 4. So these two 4s, those would cancel out. Again, they're inverses. So I have g is equal to 28. Okay. Number 2, I have m divided by negative 5 is equal to 3. Again, I see division, so I'm going to use multiplication. I'm multiplying by negative 5 on both sides. And when I do that, the 5s are inverses. They're going to cancel out. So I have m is equal to negative 15. Both of these are using the multiplication property of equality. So multiplying by the same quantity on both sides, that's multiplication property of equality. All right, 3 and 4, we're solving by dividing. So I have 9y equals 108. So I would divide both sides by 9. And 108 divided by 9, I'm not positive about that off the top of my head, so let me double check. 108 divided by 9 is 12. So I end up with y is equal to 12. So that was example number 3. And again, I'm showing my work. Even though these are pretty simple, you want to make sure you are showing your work. Number 4, I have 5k is equal to negative 115. Divide both sides by 5. And I end up with k is equal to 23. And that is going to be a negative 23 because a negative divided by a positive is a negative. Okay, and both of those are using the division property of equality. So we divided both sides by the same thing, so that's division property of equality. Helping you remember. One way to remember something is to explain it to somebody else. Write how you would explain to a classmate how to solve the equation 2/3 x equals 12. This one's a little weird because we have that fraction in there. So first thing I'm going to do is I'm going to solve it because that'll help me summarize. So I have 2/3 x is equal to 12. What I can do to solve with fractions, okay, is I can multiply by the reciprocal on both sides. So the reciprocal of 2/3 is 3/2, so I can multiply both sides by 3/2. So these two are inverses, inverse property. They're going to become 1, so I end up with x is equal to. In order to multiply these fractions, I can put the 12 over 1. So 12 times 3 is 36. 1 times 2 is 2. And if I simplify that, 36 divided by 2 is 18. So my solution is x equals 18. So what I did here to explain to a friend, to solve the equation, I would multiply both sides by the reciprocal of 2/3, which is 3/2. Okay. Next page, we're going to talk a little bit about one-step inequalities, but before we do that, we have to review how to graph inequalities. So like usual, we're going to skip this, what you will learn, and we'll go right into the vocabulary. Write the term or definition next to each. Or write the term next to each definition. Okay? A number less than 0, that's a negative number. Counting numbers, they're opposites in 0. Those are the integers. And a number greater than 0, those are positive. That should have been a really quick, easy review for you. Okay? An inequality. An inequality is a statement that compares. This is a comparison statement, a statement that compares two quantities. Okay, the statement that compares two quantities using greater than, less than, greater than or equal to, less than or equal to, or not equal to. So a statement that compares two quantities using greater than, less than, greater than or equal to, less than or equal to, or not equal to. Vocabulary link. Inequality is a word that is used in everyday English. Find the definition of inequality using a dictionary. Explain how the English definition can help you remember how inequality is used in mathematics. So in an English definition, inequality is if you experience an inequality, something is unjust or unbalanced. So unjust or unbalanced. You can think about social studies and social inequalities. Okay, so it's a situation that's unjust or unbalanced. So in math, an inequality shows how two numbers compare using vocabulary such as less than or greater than. So there is no equals unless you're less than or equal to, right? But there's no just straight equal to. So in English, unjust or unbalanced, something that's not fair. In math, it's also, you can think about a scale that's been tipped. One number is bigger, so it's heavier than the other number, which would be lighter. All right, moving on. Okay, fill in the organizer with the words that describe the symbols. We already talked about this. This one is greater than. This one is less than. This one is greater than or equal to. And this one is less than or equal to. Write an inequality for each model. All right, for this one, we have an open circle, arrow pointing to the left, so it's pointing to all the numbers that are less than -2, not including -2. So you can use any variable you like. I choose X. We're pointing to the less than numbers. It's not filled in, and it's less than -2. For this one, we have a filled in circle, and our arrow is pointing to all the numbers that are greater than 0. So this is X is greater than or equal to 0. Okay. Write a paragraph explaining how to graph an inequality to a classmate that was absent from class the day it was taught. Include an explanation of the symbols used as well as the use of open and closed dots or points. Okay, so really quickly, we use closed dots for greater than or equal to or less than or equal to. We use open dots for greater than or less than. Okay, and the arrow covers the numbers that make the inequality true. So for example, if you look back up here, the numbers 1, 2, 3, 4, 5, I could plug in any of those for X. I could plug in 1, and I would have 1 is greater than or equal to 0. So that number, that arrow covers up all the numbers that make the inequality true. All right, let's talk about how to solve inequalities now that we've done a quick graphing review. So solving inequalities by addition or subtraction. Skipping the scanning the text part, we're going right down to the vocabulary. Write a word description for each inequality symbol and write a true mathematical sentence using the symbol. So again, this is greater than, and you could have 3 is greater than -2. This is less than. 10 is less than 15. This is greater than or equal to, and you could use -8 is greater than or equal to -20, and this one is less than or equal to, and you could use -15 is less than or equal to 0. All right, taking a look down here, label the parts of the set builder notation using the phrases given below it left. Show the set on the number line. So set builder notation is another way that we could write solutions. The first thing is the variable. So first of all, this is the set of all numbers B, defining that variable. The set of all numbers B, that line means such that B is less than or equal to 5. Okay? The set of all numbers b such that b is less than or equal to 5. Okay, so to show that, we have a less than or equal to, so it's a closed dot, and we're going less than, so we're shading the arrow to the left, because those are where all the numbers less than or equal to -5 are located. Oh, sorry, it says 5, so the dot should be on 5, and we're shading to the left of 5. My apologies there, I read that wrong. All right, turning the page. So quickly solving here. First one, it says fill in the chart with the missing solution representations, all numbers greater than 3. So set builder notation would be x such that x is greater than 3. So we have all numbers greater than 3, open dot on 3, all numbers greater than 3 is to the right. Okay, this one right here, we're looking at all the numbers less than 2. So our set builder notation, we can use any variable we want, y such that y is less than or equal to 2. And in words, this would be all numbers less than or equal to 2. Okay, this one right here is all numbers that are greater than -3, so open on -3, arrow pointing to the right. Okay, oh geez, I'm making all kinds of mistakes today. Arrow to the left because it's less than goes left. So that's our set builder notation. X is less than 3, so all values of x such that x is less than 3. So in words, all numbers less than -3. Okay. Next step, write a linear inequality to represent the following problem. Then solve the inequality, provide a complete sentence answer to the problem. Raul needs at least $150 to purchase a digital audio player. Currently, Raul has $102. How much more money does Raul need before he can purchase the digital audio player? So he needs at least. At least means greater than or equal to. He can have more than 150, but he has to have at least 150. Okay? And then he already has $102, and we want to know how much more he has to add to that in order to get to 150. So we can use here subtraction to solve. We can subtract 102 from both sides. And when we do that, these two are going to cancel. I have x is greater than or equal to 48. So he needs at least $48 more. So here the property that we use to solve this would be subtraction property of not equality, but actually inequality, because this is an inequality, not an equation. Okay, moving down. Teaching someone else can help you remember something. Explain how you would teach to another student to solve this inequality. 2x plus 4 equals 3x. We're actually going to come back to that in a different lesson because it's not a one-step inequality. So we will come back to that. Okay, a little bit more. I think this is the last little part about one-step stuff. Skipping the scanning the lesson here. All right, here we go. Explain how the multiplication property of equality and the division property of equality can both be used to solve 3x equals 24. So for multiplication, 3x equals 24. I could multiply by the reciprocal, which would be 1/3. And I would get x equals 8. For division property, 3x equals 24. I could divide both sides by 3. And I would also get x equals 8. Two different ways there. All right, vocabulary link. Solve the inequality below by following the outlined steps. Okay. I don't like these steps. They're very weird. So we're actually going to skip these steps. Okay. What would make a little bit more sense here instead of adding 3x to each side? That's kind of silly. Well, what I would do is I would go ahead and divide both sides by -3. Okay. When you divide by a negative, you have to remember to flip the inequality symbol. So this gives me 6 is less than, we flip that symbol, divided by a negative, x. And then in order to set this up for graphing, we want to make sure our variable comes first, so we kind of read it backwards. X is greater than 6. And that's our final answer. So the big thing to remember here is when you multiply or divide by a negative, you need to flip the inequality symbol. That is a big deal. If you forget to do that, you're not going to get the answer correct. All right, turning the page. Okay, compare and contrast the process for solving the inequality -1/3 equals or is greater than no. Compare and contrast the process for solving the inequalities -1/3 x is greater than -12 and 1/3 x is greater than 12. So similarities, we would have to multiply by 3 in order to clear out that symbol. Differences, okay, so for -1/3 x is greater than -12, the 3 would be negative, and we would flip the symbol. For 1/3 x is greater than 12, the 3 would be positive, and we would not flip the symbol. Okay? Moving down, classify each inequality in the chart below. The inequality symbol is reversed when solving, and the inequality symbol is not reversed. So this first one, I would have to divide by 3, so therefore it's not reversed. 3x is greater than -12. 3 would be positive, so I do not need to reverse that one. The next one, I have -4x is less than 15. That -4, I would have to divide by -4. Dividing by a negative, I would flip that. So that's -4x is less than 15 in that category. Okay, -2/3 x is less than or equal to -15. I would have to either divide by -2/3 or multiply by -3/2. That is going to be a flip. Okay, next one, x minus 5 is greater than 15. I don't have to multiply or divide, so that would automatically make that a not flip. Next one, 1/4 x is greater than or equal to -8. I can either multiply by 4 or divide by 1/4, neither of which are positive, or excuse me, neither of which are negative. So that's going to be a not flip. So 1/4 x is greater than or equal to -8. -x is greater than 9. That's an interesting one. The coefficient's kind of hidden, so it's going to be a -1x. So we can think about that as a -1x is greater than 9. And I would have to flip that if I divide it by a -1. So -x is greater than 9. Excuse me. Okay, x plus 14. I'd have to subtract 14 from both sides. That's going to be a not flip because I'm not even multiplying or dividing. And then 3/2 x is greater than -7. Multiplying by 2/3 or dividing by 3/2. Neither of those numbers are negative. So that would be a not flip. Wow, I got this all in the wrong side of the column. So this one is the inequality is reversed, and this one is not reversed. So if you followed along with me, you're going to need to switch those two words right there. Sorry about that, guys. All right. Let's see how much more we have to go with one step. Good, just a little bit more. All right, we're skipping this scanning right here. All right. And let's see. The review of some vocabulary. The area for a triangle is 126 centimeters squared, and the perimeter, distance around the outside, is 54 centimeters. This is the important one right here. Area equals 1/2 base times height is the formula for the area of a triangle. Okay? Vocabulary link, addition and subtraction properties allow you to add or subtract the same quantities to each side of an equation or inequality with the sentence remaining true. List an example of something in everyday life that you have to do the same on both sides in order to keep it equal or the same. I like to think about distributing the weight on a bike. So if I'm riding a bike and I lean to one side or the other, the bike is going to tilt and I'm going to fall over. But if I do the same amount of weight on either side, that bike's not going to tilt and I'm going to be able to ride it without falling over. Last page, guys. Thanks for sticking with me. I know this is pretty long today. All right. Draw an arrow to match the correct property needed to solve the inequality, then solve each inequality. So the arrows are already drawn for you. First one, subtraction property of inequality. This is that guy here. We would have to subtract 18, subtract 18. When we do that, we end up with x is greater than 18. Okay? Division property of equality, we have 9x is greater than or equal to 27. Divide both sides by 9. We have x is greater than or equal to 3. Okay? Where do we go? Addition property of inequality. This one right here. We see a -9, so we're going to add 9. We're going to add 9. We end up with 19 is less than or equal to x. And the last one, multiplication property of inequality. I see 1/3 x, so I can multiply by the reciprocal or by 3. And I end up with x is less than 24. None of those required any flipping because we were either dividing or multiplying by a positive. So there was no flip required on those. Models of the solution for the inequality on the number line. I have -4y is greater than or equal to 24. So I would divide both sides by a -4. It gives me y is less than or equal to -6. Remember, we do that flip when we divide by a negative. So y is less than or equal to 6. Got a dot on -6, arrow pointing to the left because we are less than. Okay. In the boxes below, write examples of inequalities in which the sign does and does not have to be reversed. We're not going to do 3 examples because I think you guys probably have the hang of this. On this side, we're going to put does reverse, and this side we're going to put does not